Well, it's my huge pleasure being in this very nice webinar, and I'd like to acknowledge also Professor Kurkutas and Amalia Yanni for organizing this nice event, and of course the Journal Nutrition for actually accumulating the different expertise on this specific panel. So actually, I'm gonna indicate where we are located and where we're performing our scientific work. So we're located on the Epirus region. So this is located on the northwestern part of Greece, and we're doing the design and synthesis of compounds, their bacterial evaluation and pharmacokinetic studies. So Epirus is a region where you have many different colors. And just to illustrate a picture here with many different plants that can be identified in the region of Epirus. So Epirus is a mountainous land with a rich flora characterized by the wide diversity of medicinal plants and herbs. And it's very important to realize that nature is embracing us. So you can see here orchids, where you can see how similar is a part of a plant with a man. You can see the head, the hands, the body, and the legs. So it's very important to realize that nature is an ally with us, and we need to very fruitfully exploit the plants as a source of developing novel products for the man. And just to indicate the plant flora diversity in Greece, we have more than 8,000 species and subspecies, whereas in Epirus, there have been accumulated more than 4,200 different species and subspecies. So in Epirus, we have very rich flora. Why is this? It is because of the significant alteration and differences on the altitude. You can go from zero, the level of the sea, up to 2,600 meters. There is also a very important aspect of the floristic isolation from the rest of the Greece because of the mountain Pindus, and also there is a limited human disturbance and integrations. Furthermore, in Epirus, there are more than 60 mountain peaks above 1,500 meters. There are more than 600 kilometers of rivers. There are 4 artificial lakes. So you can see very nice numbers. However, what is the reality? The reality is that our climate is changing, and there is a massive biodiversity loss. So this was actually the part that triggered our rotation to generate the Epirus4herbs herbarium and the Epirus4herbs platform. So the specific herbarium and platform that I'm going to illustrate is actually a platform where you can unveil the unique properties of the Epirus medicinal plants and food products, and also you can utilize as a platform for a discovery of biomarkers for abiotic or biotic stress to design and develop novel products with specific signature. To achieve this, we utilize many different instrumentation. We have patented also our own technology to screen the different phytochemical profile of plants, and also we have accredited our lab with an ISO 17025. So we're here back to the nature, as we can say, where you can see that there are many different plants accumulated in Epirus. But let me illustrate more or less what we have achieved the last years. So we have established the Epirus4herbs herbarium that has been accumulating more than 1,600 different plants. So all the different plants we have performed the DNA analysis in order to identify the proper to give a proper plant ID. We have performed after the characterization, their extraction, and also their phytochemical analysis. But let me show briefly the Epirus4herbs workflow. So we start by doing the plant collection. And as I mentioned before, we have collected more than 1,600 different plants. And also for each different plant that's been collected, we accumulate specific different information like the coordinates and also the harvest period, and we record high resolution photos. Here is an example of the Epirus4herbs library of plants that are stored with a specific barcode. Having the different plants stored, we are then moving on the DNA analysis. So we extract the genomic DNA, we're using PCR, and then we perform the so-called DNA barcode in order to identify the unique plant property, the unique plant ID that we have in our hands. So through this process, we have certified plant species as characterized by their DNA. Then we move on the compound extraction. So we utilize either conventional extraction methodologies to extract the more polar or less polar components. And also we utilize more advanced extraction methods and also green extraction methods like supercritical fluids, where we fluid extraction units, where we use as an extraction solvent carbon dioxide, where you can extract by simply modifying the extraction conditions, voxes, fatty acids, and different phytoconstituents. Just to give an example, starting from salvia, you grind the plant, you add it in a specific chamber, and then you can either isolate the essential oil by using supercritical fluids, or you can use a co-solvent where you can isolate your plant extract. In all the different extraction processes that we're conducting, we're utilizing as a guidance tool nuclear magnetic resonance. So NMR is a very powerful tool that can identify not only the phytochemical constituents that are present in plant extract, but it can guide in order to find the best conditions for your extraction. So you can see here, for example, a plant extract that has been generated without powdering. And here you can see the extract that you have received after powdering. So you can see how the actually phytochemical profile of the plant extract is modified by simply performing simply more or less different approaches. Furthermore, NMR can guide you to identify the different phytochemicals or groups of compounds like terpenes, phenolic acids, flavonoids, etc. And you can also utilize not only the one-dimensional version I illustrated before, but also a two-dimensional approach. You can selectively indicate and identify different phytochemicals in your plant extract. Just to give you an example of how NMR is being used in order to guide the extraction process, here you can see a plant extract that has been that we use ethanol as an extraction solvent, and here you can see the relevant extract by using supercritical fluid extraction. So you can see how massively you and very rapidly use the differences on the phytochemical constituents that are present by using different extraction processes. So NMR can guide you in order to select the best extract conditions in order to receive in your hands extracts that are populated with a very high number of phytochemicals. Having the extracts in our hands, we then move on the phytochemical characterization and identification. For this, we utilize not only NMR that I illustrated before, but also we utilize mass spec units. So we have two different mass spec units in the lab. We have a triple quad unit where we can use targeted metabolomic analysis, but also a GitOff unit where we can perform untargeted metabolomic analysis. So by using these different platforms, you can very rapidly, you can determine all the different phytochemicals that are present on your plant extracts. And you can generate reports on the different phytochemical space that is present in your extract. So up to now on Epirus4herbs, we have analyzed more than 13,000 samples after the phytochemical analysis of the 1,600 different plant materials. But how can we use this information? How Epirus4herbs can be used? So let me show the utilization of Epirus4herbs and the Epirus4herbs platform in numbers. So up to now, the Epirus4herbs has led to the generation of 4 novel plant-based products, has participated in 1 clinical trial, has discovered in a biomarker of biotic stress, this is unpublished, has discovered 4 new compounds and also has served in many different publications. But let me illustrate what is the core of the Epirus4herbs herbarium. So this is actually the database that can be generated after assembling all the different data. So we have assembled the plants, the phytochemicals that have been characterized as a part of these plants, and also we have accumulated, based on literature, the different biological properties of the different phytochemical constituents. For instance, we know that quercetin has antioxidant activity, etc., etc. So what we have established on the Epirus4herbs platform, we have established a platform where we can correlate the chemical and the biological space, and we can utilize the space to generate new products. Just to give you an example, for instance, if you would like to select a plant that will bear potent antioxidant properties, then you need to search which phytochemical has antioxidant properties. One of these phytochemicals is quercetin, and here you can see the different extracts in our library, and also the amount of quercetin that's been present on the different plant extracts. So through this process, that is a very rapid process, you can select the plant that has the highest amount of quercetin in the specific plant material. So by using this approach, we have developed different products. Just to name some, we have developed a natural mineral water product with herbs bearing antioxidant capacity, and also we have developed anti-aging preparations, cosmeceutics, different cosmeceutics, and also functional dairy products supplemented with natural substances from the plants from Epirus4herbs database. So just to give you an example on how the Epirus4herbs database can be used to develop novel products. So as I mentioned before, the Epirus4herbs database has actually correlated, because the effort, the phytochemical space of the different plants and also the biological space. And let's, for instance, indicate that we have a target. We have a target to generate a novel plant-based product that will have the capacity to protect from LDL oxidation, to protect from reactive oxygen species-induced DNA damage, to bear antimicrobial activity, and also prebiotic activity. So it's a very, very challenging task. So by using this correlation of the phytochemical and biological space, and by screening the Epirus4herbs database, the plant that came out was as a potential hit was Salvia officinalis. Then we select the plant, we perform the extract, we characterize by using DNA barcoding, we analyze all the different phytochemical constituents to verify the phytochemical content. So on the Salvia officinalis, we identify more than 100 different secondary metabolites. And then we started the biological application of this plant extract. We start first on evaluating the potency of Salvia officinalis on having an inhibitory effect against the oxidative modification of LDL. And we're quite happy and fascinated because we found that Salvia officinalis extract has a very potent effect in inhibiting LDL oxidation. So Salvia officinalis extract can be used as potent inhibitors of oxidation stress in supplements, for instance. What about the protection that can be offered by Salvia officinalis in the protection of our DNA from damage that can be induced by reactive oxygen species? Here is the result. So you can see here in this chart that in HeLa culture cells that upon the induction of reactive oxygen species in cells, we have a massive DNA damage. But when we enhance the concentration of Salvia officinalis, you see a very nice reduction of the damage that happens in our DNA that is being actually achieved simply by utilizing the specific plant extract. So another result here that we can see is that plant extracts can be used as natural antioxidants in functional foods. What about the biological activity against microbes? And we're really happy here. I would like to indicate we have established a very fruitful collaboration with the very powerful lab of Professor Kulkutas that has done all this beautiful experiment for us. So Professor Kulkutas, he evaluated the antimicrobial activity of the specific plant extract against spoilage and foodborne pathogenic bacteria. And we were quite excited because it has been identified that the Salvia officinalis extract was able to inhibit the activity of the different microbes. So the specific plant extract could be utilized as a natural biopreservative in foods. What about the prebiotic activity, the growth stimulator activity on the good microbes, on the probiotics? So here, the relevant experiment has been conducted on Lacticase Bacillus rhamnosus, where we can see here that when we have been enhancing the concentration of the specific plant extract, we reach a specific concentration where we can enhance and we can stimulate the growth of the specific probiotic. So plants could be used as prebiotics in functional foods. So if you would like to read more about the specific work, we have just published the paper where we have discovered the first plant that bears prebiotic properties and also biopreservative properties. What is very important here that has been established in Greece an infrastructure in order to chart the microbiome and its application in food systems, where we have actually heavily utilizing this specific platform to generate and develop novel products. So one of these products that came up from this scientific work is the plant-based product that's called Probiogi, where we have actually enriched this specific product with Salvia officinalis, our prebiotic that we just discovered from the research that we've been illustrated before, and also with probiotics. The specific product has been showcased in different events, and we're quite excited because we received very rewarding comments. So I would like just to close my presentation indicating that Epirus4herbs, it is a powerful tool that you can analyze the phytochemical space of plants, we can chart plant biodiversity, and you can develop novel products. And this is quite interesting since you can standardize plant extract phytochemical content and you can correlate it with biological activity and utilize this information as a natural matrix in functional foods. I would like to close my presentation as I started, simply indicating that we need to respect and coexist harmoniously with nature. Nature is our ally, and we need to fruitfully exploit in order to generate novel products for us. So I would like to thank all of you for your attention, my group, and all these fantastic colleagues that allowed us to make this discovery happen. Thank you.